Today we're going to look at forces in vertical motion. Before I do that, I'll get a quick review that if I had an object with a force of, say, 30 newtons this way and, say, 10 newtons that way, the mass was 2 kg, and I wanted to find what was the acceleration on this object, assuming there's no friction. Then I'd first, obviously using Newton's law, F net equals ma, I first find the net force, and I have plus 30 minus 20, or minus 10, excuse me, which gives me a plus 20. So plus 20 is, what I'm going to left up with once I add up these two vectors, one going positive and one going negative. And basically I could rewrite that F net as, everything to the right is positive, so 30 newtons positive plus a negative 10 newtons, and that's going to equal to my mass times acceleration. And so, when I find the net force, it's just the same 20 newtons, so 20 equals ma, and that's basically how I go ahead and then say, well, 20 newtons equals 2 times a, divide both sides by 2, and so acceleration would be 10 meters per second squared. And so that's basically how we've been doing questions, where you first find the net force, and you know that F net equals ma. Once we find the net force, we can equal to mass times acceleration, and things go on. Well, a similar thing would happen with vertical motion, of course. It would be no different. Let's say I have an object here, and it has a force downwards of, say, 60 newtons, and a force upwards of, say, 20 newtons. Well, that translates to 40 newtons down. And so, again, if I know the mass of this object, then 40 newtons divided by the mass would give me the acceleration. And so this is a pretty simple way to work through these questions. Again, all we're doing is using Newton's second law. But when we start looking at questions where we say, if I say I drop something and the mass is, say, 2 kg, and I'm going to use, so my force of gravity, which is mass times gravity, is going to be 2 times 9.8, or 19.6 newtons. And that's downwards, it's negative. And so that's the force of gravity pulling it down. Well, let's say I've had a force of friction of, say, 3 newtons that was slowing it down as it was going up. Well, then again, you would simply say, well, negative 19.6 newtons plus 3 newtons. That means all I'm doing is adding up the forces on the left-hand side and set that equal to mass times acceleration. So that's negative 16.6 newtons is equal to 2 times the acceleration. So the acceleration would be negative 16.6 divided by 2, or negative 8.3 meters per second squared. And so that would be the acceleration of the object as it comes down. And that's all pretty simple and kind of nice to look at, but a lot of times we're not just going to be asking for the acceleration. Sometimes you may be asked, well, what's the force of air friction? Or another time you might be asked, well, what is the G on this planet if I don't give that to you? Or maybe even the mass of the object by giving you everything else. So what I'd like to do is go ahead and make a free body diagram for an object falling. And this will be a model that you can use for any object falling down while there is air resistance. And this doesn't have to be on Earth, it could be anywhere. It's just a basic model for this particular thing happening. Anytime I say an object is dropped and there's air resistance, it's going to look something like this. And so what I want to do is make a free body diagram. Remember, the free body diagram for this is pretty simple. F air, in fact, it's already made up there, and Fg. And then our first step is to make our free body diagram, and the next step is to write the equation. Everything up is positive, everything down is negative. So we have F air minus Fg is equal to ma. And this here Fg, if you recall again, is nothing but the gravity force pulling the object down, which we also call the weight of the object, which is its mass times gravity. So I'm going to replace the Fg with that, and I have F air minus mg equals ma. And this could become your go-to equation for every time you have something that's falling through the air and there's air resistance. And so what we'll do is next is look at a question that asks for something particular and see if we can figure out using this equation. Remember, we have here 1, 2, 3, 4 variables, so as long as we have 3, anything fourth can be found, be fair game. So we'll look at that in part 2.